The cosine values for special angles are well known. However, to determine the cosine values for general angles, a somewhat special process is required, and that is the cosine sum and difference identities. Consider two general angles, U and V, drawn on the unit circle with their initial sides. Connect the intersections of the two angles on the unit circle and label the angle between them as theta. The coordinates of the two intersection points A and B are defined by their respective cosine and sine values. We can find the length of segment AB by the distance formula. Draw an angle theta in the first quadrant, mirroring the angle on the unit circle. The coordinates of 2 points, C and D, on the unit circle are determined. We can find the length of segment CD similarly using the distance formula. The chord length for the same angle theta is equal for both points. Apply the distance formula obtained earlier for both pairs of points. Square both sides, expand the terms, and collect like terms. Combine the cosine squared and sine squared terms for angle U, and do the same for angle V. On the right side, add the cosine squared and sine squared terms for angle theta. Simplify the equation. And then, using the identity that the sum of cosine squared and sine squared is equal to 1, combine the constant terms. Subtract 2 from both sides. And divide both sides by -2. As theta is the difference between general angles U and V, the cosine difference identity is derived. Now, let's explore the cosine sum identity. Express U plus V as U minus -V, and substitute -V for V. Apply the odd-even identities learned in the previous lesson. This results in the cosine sum identity. This is known as the cosine sum and difference identities. Let's consider an example. Pi over 12 corresponds to 15 degrees, so subtracting 30 degrees from 45 degrees gives the angle for which we want to find the cosine value. Apply the cosine difference identity. Assuming familiarity with cosine and sine values for special angles, simplify the numerator, add the two fractions, and obtain the value for the general angle without using a calculator. See you next time.